Alright guys, this second video, we're going to take a look at an example. We're still going to look at sine, but we're going to take a look at when n is even. Remember I said the first thing that you should do is identify n, because n is going to give you the symmetry, and it's also going to give you how many petals you get. And here's an example right here. Right, in this case, n is 2. So since n is even, the graph, no matter if it's sine or cosine, it's symmetric to all of these, x-axis, y-axis, and origin. And you can see how it's symmetric to all of them. You can fold it over the x-axis, y-axis, and origin. These petals are going to lie on top of each other. Now, a little bit different for this one than the last video. The number of petals, if n is even, you double n, right, 2n, and that's going to give you how many petals. So you can see, for this one, since n is 2, you double that, see how you get 4 petals right here? Alright, so that's the first thing we're going to do. Then after that, you really rely on getting max, min, equilibrium, the period, the increments, and then you're going to get those points. Alright, so let's go to number 2. That's going to be one where n is even for sine. So it's on the next side. Alright, so number 2. This one's going to get a little bit ugly because n is 4. Now the very first thing we're going to do, what is n? So n is 4. So the first two things we should figure out is how many petals is it going to get for the rose curve, and what is it symmetric to? Since n is 4, the number of petals is 2n. So we double it. There's going to be 8 petals here. So there's going to be a little bit more work for this one, because we're going to get 8 points shooting out from the origin. Symmetry, since n is even, it's symmetric to everything. Y-axis, x-axis, and origin. Let's just put y and x-axis. Alright, now the period, remember we said it's 2 pi over b, but in this case it's 2 pi over n. In this case, n is what, the 4? So 2 pi over 4, that reduces to pi over 2. The increments is we take the period, divide it by 4, and in this case it's going to give us pi over 8. Alright, so with theta right here, we're always going to start at 0, but then we're going to go up by pi over 8. And we're going to keep adding pi over 8. And I'm not going to show everything from 2 pi because that would be a lot of points. So we'll kind of do the shortcut using symmetry. But let's move this over. And let's get max, min, and equilibrium. So once we have petals and symmetry, we're really relying on our previous lessons on graphing sine and cosine waves. So, alright, so since the amplitude's 3, there's no vertical shift. Since the amplitude's 3, our max is 3, our equilibrium is 0, right? That's going to give us points at the origin. And then the minimum's negative 3. So right here, these 3 values, these are the only values we're going to get for the radius. Okay, now I want to get the values for theta first. This is where increments really comes in handy. So I just go up by pi over 8. So we'll have, we start with 0, so then we're going to go to pi over 8. We're going to go to, we add pi over 8 to that, we're going to get 2 pi over 8, which is pi over 4. Then we're going to get 3 pi over 8. I'm trying to squeeze it in here. Add pi over 8 to that, you get 4 pi over 8, which is pi over 2. Add pi over 8 to that, we're going to get 5 pi over 8. Again, this is probably the hardest part, dealing with the fractions. Add pi over 8 to that, we're going to get 6 pi over 8, which is 3 pi over 4. And then we're going to get 7 pi over 8. Whoops. And then we're going to get pi. Alright. Now let's just leave it right there. That's the hardest part. This is going to be the easy part. Now remember sine, it always starts here at the equilibrium. So 0, 0. Let's put that point. Let's zoom out so we can include the graph on here. So 0, 0 is right here, right at the origin. We're always going to get that point. Okay, then since it's the amplitude's positive 3, we're going to go up to the max of 3. All right. Now, pi over 8, that would lie like right between pi over 6 and, what's it, pi over 12? So pi over 8's like right here. And that's at 3. So let's go to the third circle there. 1, 2, 3. It's like right here. Oops. Kind of tough to do on the iPad. All right. Now, this is where we're going to use symmetry. So I don't have to go on this chart all the way to 2 pi. This is symmetric to both the x and the y-axis. If I take this point and I fold it over the y-axis, it's going to be like right over here. It's going to be in between the 5 pi over 6 and what's that, 11 pi over 12? It's going to be like right here. So let's put that point right there. All right. So, and we're at the third circle. 1, 2, 3. It's like right here. This is really hard to do. All right. Then the other thing, it's also symmetric to the x-axis. So if I fold this over the x-axis, it's going to go down here. Again, it's going to be between, the 6 and the 12. It's going to be like right here. All right. Like this is going to be the, whatever it is, pi over 8. We're going to get a point right there. All right. So it's like right here. All right. And then this, we can even take this. This, I can fold this. It's going to be symmetric to the y-axis. So I fold it over here. It's almost kind of like I fold it over here. So again, it's going to be between the pi over 12s and 6s. All right. So it's going to be like right here. All right. So let's put that point right there. Wow, this is really hard to do on an iPad. Bear with me. All right, so it's that point right there. So just like that, we're halfway there. We have 4 petals. We can even draw them in. Again, I'm not going to be real picky with how wide it gets. All right, but we're halfway there. Those are 4 petals. And they're all symmetric to the x and the y-axis. Now to get the other 4, let's just follow the pattern here with using the max, min, and equilibrium. So we ended at the max, so the next has to come back down to the equilibrium. Then at 3 pi over 8, we're down at the minimum of -3. All right. Now let's keep going. So then it's what, at 0. Then we have to go up to the max of 3. All right, let's graph this one. The 5 pi over 8. If I were to graph that, that's in the second quadrant. And 5 pi over 8, that would be right in between. This is why this is a tough one. Right in between these 2 angles. Right, 5 pi over 8 would be right here. So it's in between the fractions that have a bottom number of 3 and a bottom number of 12. So let's put a point there at the third circle. 1, 2, 3. So it's like right here. All right. All right. So now what I'm doing, I'm going to take this and I'm going to fold this over the y-axis. So it's going to be, again, between the bottom number of 3 and 8. This actually is going to be, I believe, the 3 pi over 8. So you're going to get a point right here, like right about there. All right, so let's put that in there, like right here. All right, then we just use symmetry to get the other 2. If I take this and fold it over the x-axis, it's going to be between, again, where the bottom number is 3 and 12. It's going to be like right here. All right, so let's put a point right there, like right here. All right, and then to get that last petal, then I can just fold this over the y-axis, and again, it's going to be between the 3 and the 12 for the bottom. Then, not all of these are going to be this ugly with these fractions. That's the last pedal. It's going to be right there. All right. Like right here. All right, then I just draw. My rose is not looking too good. All right, I just draw it, and I have the 8 petals. You can stop there. Technically, we could have stopped like right here. If I graph this, the 3 pi over 8 negative 3, 3 pi over 8 is like right here. Negative 3 would move it down here. All right. So use symmetry so you don't have to waste your time like I did on the first video. I'm getting on all these angles. All right, so get N first, get the pedal symmetry, then you really rely on your max min equilibrium, period, and increments to get the graph of the rose curves.